All right, this is going to finish up chapter 3 for my class anyway. Um, Word problems. We're just going to kind of separate this and have like a little quiz on just this. We're going to start off with money stuff, interest, compound interest, stuff like that. So it's a little bit interesting. The stuff you need to know. This is one of the real life applications of these things that we learn. There are two types of investments or interest problems that we're going to do in this class. One of them is periodic compounding. That's usually what happens. That's when the bank adds interest like once a month or something like that. Then there's continuous compounding, and that's when interest is continuous, like it's always added. They never stop adding interest. The way I think about it is pretend there's somebody at the bank whose job it is to add interest to every savings account, and there's a button behind the counter, and every time they hit that button, they add interest, whether it's 10% or 2% or 1% or whatever. But every time they hit that button, interest is added to your account, and they hit the button, if it's periodic, they'll hit the button once a month. So it'll be like interest once a month, and they'll just keep hitting that button once every month. Now, continuous compounding means that that person sits down on the button and keeps the button pushed and never lets go. They're continuously adding interest. And so those are the two types of problems. The two formulas we're going to use, and they're kind of hairy, but here they are. You have periodic compound interest, A equals P times 1 plus, you can read that. A is the accumulated or the desired amount of money. P is what you start with. It's your initial deposit, your principal. R is the interest rate. Just make sure you change it to a decimal, so like 5% would be 0.05. N is the number of times the interest is compounded in a year, so make sure you factor in it's how many times over the course of a year you add interest. And time for the money problems is going to be measured in years. So this is if interest is added every month or every week. If it's periodic but not continuous, it's this formula. Continuous interest is with this formula. P and A and R and T, they're all the same thing. It's your accumulated amount, your initial amount or the deposit, your interest rate, and time. E is not a variable. E is 2.71828182845904523, which you all should know to 17 decimal places. And we will simply use the E button in the calculator to work these problems. So please do not put anything in for E. It is a constant. It is not a variable. So a couple of examples with money problems. And you have to make sure you pull all of the information out. And the first thing we need to do, if it's a money problem, is decide if it's compounded continuously or periodically. And this one, if you read the problem, it says this is compounded monthly. That's periodic, which means we're going to use this formula right here, the uglier of the two. So let me get a screenshot of this formula, and we'll pull this in over to work that problem. So let's see. So here's my formula that I'm going to use for this problem. And now we have to pull all of the information. Let's see, we deposit $2,000. That's going to be P. So P is 2,000. In a money market that gets an annual interest rate of 5.5%, now your interest rate, R, is going to be 0.055. Remember to move that decimal over 2 spots. And compounded monthly. Okay, if something is compounded monthly, how many times in a year will that be compounded? Well, that'd be 12 times in a year. And then I want to know how much money do I have left after 2 years. So T is going to be 2. And what we don't know is A. We're going to try to find out how much money I'm left with. So we will simply throw all of this into the formula. So A is, P is 2,000 times 1 plus R, which is 0.055, over N, which is 12, all to the NT power, which is 12 times 2. And we are going to throw this in a calculator. Just please be extra careful with your parentheses. You need to make sure you trap 12 times 2 in parentheses. If you want to be fancy, you can call that 24. But we're just going to throw all this in the calculator. And I'm going to throw it in one big swoop. Now I'm going to have to go back and forth. I want to show you my calculator here. Where's my calculator screen? There it is. So here's the calculator. And we're going to punch in this problem. It was 2,000 times, and I'm going to have to go back and forth here. Let's see, 2,000 times 1 plus 0.055 over 12. So 1 plus 0.055 divided by 12, close parentheses, to the power of, and then it was 12 times 2. So 12 times 2, and I'm simply going to punch it in like that. I'm not going to try to do some cleaning up in the middle, you can just throw it all in the calculator at once, hit enter, and I get 2231.995. 2231.995, and that is, I'll just take a screenshot of this and throw it on the put it right here. There we go. So now we can see it, and we get, once I throw that in, we get A to B. Oh, lost my pen. A is 2231.995. We will round that to the penny because this is money, and I will round that 9 up, and that's actually going to round to 2232.00. So there's how much money we have after 2 years. So we gained a little over $200 in interest. Okay. Here's another problem. I want to buy some gnome repellent that costs $3,000. Bank is giving me a savings account and gets 3% compounded quarterly. Okay, that's an interesting word, quarterly, because quarterly tells me that we are again going to use this formula for periodic compound interest, which means we need to find A, P, R, N, and T, and we have to pull that information from the problem. So let's read the problem. I want something that costs $3,000. So I want $3,000. That's the desired amount. It doesn't say I'm starting with $3,000. It says I want $3,000. So $3,000 is going to actually end up being A. I'm going to fill that in at the end, though. My bank gives me an interest rate of 3%, so that's going to be 0.03 for R. Compounded quarterly. Now, quarterly is going to be 4 times a year. So N is going to be 4. How much should I deposit? There's the question. How much should I deposit? That's saying what should P be? So P is the unknown. I want to know how much to put in the account so that I accumulate 3,000. So 3,000 is the final amount. I want to find out what P is, and I want to buy this repellent after 2 years. So we're going to throw all of this in my problem. So A is 3,000. Notice I've put my variable in a different place this time. P is unknown, 1 plus 0.03 over 4, all to the 4 times 2 power, N times T. And there we go. Now for a problem like this, we need to solve for P, so we're going to do a little bit of cleaning up. What I could do, let's see, actually, I could go ahead and get the decimal approximation for all of that. 1 plus 0.03 over 4 to the 8th power. So let's punch that in. So it was parentheses 1 plus 0.04 over 3. No, it was 03 over 4, wasn't it? 03 over 4 to the, and it was to the 4 times 2, which is the 8th power. And I get that decimal. Now, one thing I don't want you to get into the habit of doing is rounding your answers. So I punched that in the calculator. Geez, I'm going to get stupid half screenshot. Let's try that again. There we go. So I punched the inside of my calculator. Now that's a big decimal. So what I'm going to do, it is about 1.062. So I'll say 3,000 is equal to P times, and all that stuff in red is about 1.062, but I rounded. You really don't want to round answers in the middle. So I'm going to do something in my calculator called storing your answer. So what I'm going to do, I need to reuse that problem. So I'm going to store, and if you look next to your 1 button right here, and the same on the 84s, there's a button that says STO, and if I hit that button, so I hit that button, if you look at your screen, it now says take the answer and store it. So it says ands stored. I'll just hit alpha A, and I'll hit enter. And now every time I hit A in my calculator will see the decimal 1.0615 crap. And so all I have to do is hit A, and it recalls that value. So I'm going to make a note to myself that this is stored for A, right? So 1.062 is stored in my calculator as A, and now when I solve this problem, I will divide by 1.062, 3,000 divided by 1.062, and I will get a value for P to be 3,000 divided by that, but in my calculator, I'm not going to hit 3,000 divided by 1.062. I am going to hit 3,000 divided by A, because I stored my answer. So 3,000 divided by A is 2825.93. And so I get an answer of 2825.93. And that's how much money I need to deposit in order to have $3,000 after 2 years. Okay, good? Okay, good. Did I get that right? 2825.93. There we go. Questions, comments, concerns? Questions, comments, concerns? So we're sitting at 10 minutes. That's pretty good. All right. Let's see. Here's another one. I want to double my money. Now, this is an interesting problem. We are compounded weekly, so once again, we are dealing with this same formula. This is the one we're going to use more often than not, which means I need to find A, P, R, N, and T. And so let's read the problem and see what we can find. Interest is 6%, so 0.06 for R. Compounded weekly. Now what you need to know is there are 52 weeks in a year. 52 weeks in a year. You need to know that. So N is 52. And I want to know how long it will take my money to double. Now how long is a T or a time question. So we don't know what T is. We don't know how long this is going to have to bake in order to double my money. So T is unknown, but the weird thing is they didn't give us my initial amount and my accumulated amount. So what we're going to do, we have a couple of options. We could keep it vague. I could say, well, you know what? I don't know what I start with. I start with P, and I know I want to double that. I want to double my initial amount, so I'm going to say my accumulated amount is 2P. Now, some people don't like the vagueness of that. Well, what actually works is you could just make up numbers. So somebody out there pick a number. Hey, that's a good number. Somebody said 5. So let's say I start with $5. If I want to double my money, then that means that I am shooting to get $10. High rollers here. So we're going to deposit 5 and get 10, and that actually will work. So we're going to plug all of this in. So my accumulated amount is going to be 10 is equal to 5 times 1 plus R over N, which is 0.06 over 52, all to the 52T. And we need to solve this equation. And this one, in my opinion, is the most difficult kind to solve because my T, my variable, is in the exponent, which is what we were solving on that test we took not too long ago. So if I'm going to solve this, the first thing I'm going to do is divide by 5. I have 5 times stuff. I'm going to divide by 5. And when I divide by 5, I will get 2. Now that is why it doesn't matter what numbers you pick. If you pick 10 and 20, your first step you're going to divide, you will always end up with 2. So I have this to the 52T. And now I'm going to clean up the inside doing exactly what I just did on that last problem. I'm going to punch 1 plus 0.06 over 52 in the calculator. There we go. So I punched that in the calculator, my inside right there. Notice I also stored it for A. And even though I did have A previously stored for this problem, once I chose to store something else, it overwrites it. So on my paper, I'm going to write 2 is equal to, and my inside right here cleaned up to 1.001. I'm going to write that on my paper, but when I work this problem in my calculator, I need to be aware that 1.001 is now stored in my calculator for A. So every time I need this decimal, I'm actually going to hit A. Okay, so here's where you're going to get angry because I need to solve this, but my exponent's in the variable, so we will have to take the natural log of both sides of the equation. And the reason I do that is because now, on the right side, I can take this exponent and pull it down front. That was the whole point of taking the natural log. So I can take that exponent down front, so it's going to equal 52 times T times the ln of 1.001. And now to finish solving for T, we have one more step. I'm going to divide by everything except the T. So 52 times the ln of 1.001. So divide by 52 ln of 1.001. On the right side, 52 cancels, ln 1.001 cancels, leaving me with only T. And on the left side, I'm going to throw that in the calculator. Make sure you trap your denominator in parentheses. That is vital. So make sure you put that in parentheses. All right, so there I punched it in. And notice when I punched it in, I didn't hit ln of 1.001, I hit ln of a because a was stored for that value. And the reason I do that is because it gives me a much, much, much more accurate answer. Much more accurate. So you want to use stored values, don't use rounded values. And there's one more problem here. I think there's just one more. I see two more decimal space problems though. Ooh, that's weird. See, I have one problem. Yeah, there's just one problem. There's a blank page. That's what scared me. All right, so last problem. This one, if you notice, is compounded continuously. Now, continuous is nice because the formula is cleaner. It's just P e to the RT. So I need A, P, R, and T. And remember, E is a decimal, 2.7-ish. So I deposit 700. That's my initial amount. Gains 8% interest, 0.08. How much do I have after 10 years? So T is going to be 10. We're looking for A. So this problem is going to set up kind of nice. A is P, 700, e to the 0.08 times 10. That's going to be our problem here. We'll punch that in the calculator. And hang on, I'll pause it while I punch that in. And you use your E button. Please don't punch in 2.7. You have an E button on your calculator. There we go. So I punch it in, and I get, first make sure you watch your parentheses. It is e to the power. Make sure all that's in exponents. And we get an accumulated amount of $1,557.88. We're going to round to the penny because that's how we do things in America. And there we go.